Good evening, everyone. Welcome to 12th live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta, and I'm a PMRF fellow and a PhD scholar from IIT Guwahati. And this is going to be your last lecture, lecture 12 for this particular course. So, in this particular course, I will cover key concepts from week 12, which is concept selections using scoring method, and the deadline for the last assignment is tomorrow, 19th October. And if you have not finished the assignments, please finish them on time. So in this particular lecture I will cover some of the key concepts that will be helpful to solve those assignments. So here is what we have learned in the last lecture. So in the last lecture we discussed about gallery method, which is another intuitive method for concept generation. So basically we had two methods. One is intuitive method, another is logical method. And in intuitive method previously, last class we learned about brainstorming and 635. And then in the last class we discussed that gallery method is something which is like a combination of both brainstorming plus 635. Okay. So benefit is that in brainstorming, the ideas are not very directed towards the functional requirements. Similarly, issues with 65 is that we have very limited number of people who are involved in 65 process, because there are only 6 people involved here. So combining both, what we have is a process called gallery method, where uh, very similar to brainstorming. Initially, a team leader first give an introduction to all uh, the problem area and what solution space a particular team is looking for, and then there is a phase which is a ideation phase one, and where all individual participants generate concepts. Okay, so this is done at individual level. Okay, so this is at individual level. So what next they do, they hang all the concepts. Okay, they hang or they can fix it in a wall, and then participant we review, all the participants review all the concepts, and then they suggest improvement to each other's concepts, and then again ideation phase 2 happens. Again the new set of concepts get generated, and this particular process repeats for a certain number of times, and after that there is a selection process they carry out. Next thing what we talked about was a logical method of concept selection, which is basically a more systematic way of generating a concept. So we discussed something called trees, uh, or tips. So trees is a abbreviation for a Russian word, and tips stands for theory of inventive problem solving. So which is basically that a Russian scholars, after reviewing 400,000 patents, he identified that all inventions are basically contradictions. Okay, contradictions to some solution, to some previous solution. Okay, previous solutions. And what he identified was that these contradictions can be generalized. Okay, so these contradictions can be generalized to 39 engineering parameters, and these 39 parameters can be later solved by using 40 engineering principles. Okay, so what we have as a tool in a tips method is that we have a list of 39 engineering principles which is already available. Then what we have is a uh, contradiction matrix. It's called contradiction matrix, where we have a 39 by 39 matrix of these engineering parameters. And for our concepts, whatever parameters we select, we find if there exists any sort of contradictions. For example, weight is a parameter which is contradicting with speed. Okay, so in this particular contradiction matrix, there will be numbers in this particular slot, for example 2 3 4, which will belongs to a set of 40 engineering principles. So this is another set of rules or engineering principles that were provided to us, which basically have numbers 1 to 40 of different engineering principles. For example, break or combine, or counterweight, something like that. These are all various such engineering principles are provided here, and based on our contradiction we can identify the particular engineering principles that we can solve, and by referring to this particular chart then we can think about concepts based on these principles. So this makes the overall solution space a bit easy to reach. Otherwise, people can take ages to identify a certain number of concepts. So this saves a lot of time, and also it increases efficiency of developers or designers in the ideation process. Okay. Next was concept selection, which is basically soon after concept generation by either of the intuitive method or logical method, we go for concept selection. So during concept selection, we first do concept screening. So concept screening means we have 500, for example, concepts out of a concept generation phase, and then we try to reduce it to certain numbers which can be workable. Okay, for example, 46. Then we go for concept scoring, which is a more detailed way of selecting further concepts. So then we can read something like two, three concepts, and then we can go for, sorry for the interruption. Okay. So if you have any question, please use the message box. Okay. A lot of people are joining late today, so sorry for that interruption. So concept scoring, after concept scoring, we can go for concept testing. So using these two three concepts, we can go for concept testing and then identify the best suitable concept after doing user testing. Okay. So this was what we covered. So what we covered was a path matrix. So I will discuss what is a path matrix. So last time I already discussed that when we have different concepts in a path matrix, we first create a reference, okay, which we consider as something zero. We give score of zero for all the criterias, okay, because we take that as a benchmark. And then on the left side of the table we place the various criterias against which we want to compare all the concepts. Okay, so these are various concepts. Antimicrobial dressing is a concept. So what we discussed in the last class was that there's a project where we developed lot of concepts for faster wound healing. Okay, so these are various concepts for faster wound healing, and the concept lies in various domains. So few are based on antimicrobial dressing, few are based on electrotherapy, so C2, few are based on mechanical suction C3, then ultrasound based were some, then there were negative pressure wound therapy, NPWT, and cold plasma. Okay, so I just grouped all those concepts and try to see how those can be uh, selected. Those can be used via a path matrix to select the best uh, possible concepts that we can go for. uh, so basically we had these are one, two, three, four, five, six criterias: cost, tech complexity, safety, ease of use, portability, effectiveness. And what we do in pug matrix is that based on our reference, which is a standard dressing procedure, we try to see if this particular criteria is a positive feature or a negative feature in this particular, for this particular concept. For example, antimicrobial dressing will be a bit costly than standard dressing procedure. That's why it's a negative feature. Similarly, technology complexity will be less because here there are a lot of consumables, lot of skill dependency required when you actually want to do a standard dressing procedure. However, a antimicrobial dressing will be something that can be easily used by someone who is not even skilled, who is not even a skilled healthcare professional. So in terms of technology complexity, this is a bit in the positive side. Okay, so this is less complex, that is the positive. Safety wise, it is same. Ease of use, same. Portability, it is more portable because you have, here you have to carry a lot of things. This is like a one single dressing, then it is more effective. Okay, so these are positive. Similarly, for every concept we can do the same thing. So we wherever we find compared to the standard reference that this is a positive feature, we say positive. If it's a negative feature, we say negative. And then what we do, we add all the positives and negatives. So total positives here, one, two, three. Total same is like 2, so we do not count actually the same. Negative is 1, so overall is actually 3 minus 1. This we do not consider, so this is 2. So likewise, for all the concepts we may have different scores. For example, NPWT probably 4, cold plasma 5, ultrasound 1, mechanical 1, then electrotherapy 3. Then these are the various scores that we generates using a bug matrix, and then based on these ratings we give our ranking. So highest, the one which is having the highest score, we can give the ranking 1, ranking 2, ranking 3, 4, 5, 6. Sometimes what happen, we may not like some of the features. Okay, some of the features we find same, but some features we see negative here. But we see some sort of possibility of combining some concepts from C2 to C1, then probably we can combine two concepts together, and that way actually we can add up the scores. Okay, and then we can actually increase the scoring. Okay, so this is an example like how we can use pug matrix. So the limitation of pug matrix is that it is useful for concept screening, but it's not very useful for final concept selection. Why? Can you tell me why? So you can use the message box. Okay, correct. So one thing what you said is correct. Like here we cannot compare between concepts. Okay, here we are only comparing against a standard, some reference. Okay, that means what, we are either getting minus or minus, or plus or minus. Here we do not know, we can certainly find somewhere like, okay, this is plus, this is minus, But if there are concepts having similar, positive, we maybe C4 is more positive, okay, than C3. So in that case, there should be some way where we can figure out that the cost of ultrasound device, that particular feature, is more positive, okay. But that we can't do using the standard bug matrix. Similarly, if something is negative, and again some feature uh, in another concept is again negative, there is no way we can actually figure out like which is more negative. And when we actually add up these things, we consider all of these uh, criteria of equal weightage, and that generally does not happen when actually in a practical case we select concepts. Because sometimes, not sometimes, like in always, like in a medical device, a effectiveness of a treatment is always given a higher weightage. Maybe a particular concept, the effectiveness is so high that you can actually compromise on the cost. For example, cancer, if some device is effective, you should not look for the cost of that particular concept, because having a 100% effective solution is the key goal in a clinical solution, okay. Similarly, safety again should have a higher weightage than rest of the criteria, but that's not possible using a Parks matrix. So these are two basic negatives of path matrix, why it cannot be used for final selection of concepts. It's mostly used for concept screening, where actually based on some references you can actually select at least few. Okay, if there are 500 concepts, then probably you can reach something like a 46 or 40, that level concepts you can reach using Parks matrix. But after that, what happens, like comparing these 40 concepts based on their features, it became difficult because there is no instrumentation that this particular matrix provide. So for that, what we do, we use a technique called weighted index method, which is another matrix used for concept scoring. So what we do here is basically, this is again a similar example. However, here I considered only three concepts, okay, to make this particular comparison a bit easy. So what we considered here are three concepts: electrotherapy based concept, then ultrasound based concept, and a cold plasma based concept. So I'll come to that soon. So these are the criteria that previously we have selected. So basically we had cost, technology complexity, safety, ease of use, portability, effectiveness. Now here, if you see, effectiveness is given a very high weightage. Similarly, portability also given a very high weightage, and the third high weightage is given to safety and ease of use. Okay, so this is like third, this is second, this is one, and technology complexity, well, like we don't care, like then cost is okay, we give some priority. So technology complexity is not a issue, very less, like 5% weightage is given to technology complexity. So what we do here is like we rate first individual concept against a fixed rating. For example, for a scale of 1 to 5, okay, what particular rating you will give for this particular device. So let me explain first what is a electrotherapy based concepts. So electrotherapy basically is a technique where if you have a wound site, so this is a chronic wound site, what we do, you place a cathode and a positive field outside, and because of this electrical field difference, what happens, the epithelial cells, they starts moving towards the center, and this particular way your open wounds get healed and it becomes closed. Basically, you it starts formation of scar tissues because of the flow of the epithelial cells. Similarly, ultrasound based devices, they do not have much clinical evidence, but in many researches, they shows that when you use some sort of ultrasonic vibration in surrounding area of a wound site, okay, because of those vibrations and the frequency, there is again a movement of microbial actions, cellular movements, and because of that, there is a faster healing of chronic wounds. Okay. Under is cold plasma, which is a bit complex in nature. What is cold plasma is basically we have plasma. Plasma is something which is not fire, but it is a electrical high electrical potential. When we create a high electrical potential, like very high voltage, okay, and we try to create some sort of grounding, okay, using our body, human body. So there is some sort of plasma generation at this particular area. So what happened because of those plasma, the oxygen and the water molecule get breakdown, and what they form is something called as H2O2, hydrogen peroxide. Because of hydrogen peroxide, this have microbial antimicrobial action, and this helps in faster healing of uh, you know uh, infectious wounds. Okay, so this is again a technology which is proven. However, it's very expensive and very you need to be it's very safety wise, it is not easy to manufacture, so you need to consider a lot of design decisions to arrive at particular design. Okay. So in terms of technology, this is a bit complex. So if we try to rate this thing cost wise, okay, so cost wise, electrotherapy out of 5. It is electrical potential, so you can use simple battery. Again, the signal is again in a pulse modulation form, so very small voltage current is given surrounding the wound site, and in terms of cost, it will be low cost. So I'll give a higher rating because this particular is positive here. So I'll say it is a 5 star. Okay. Compared to that, if we say ultrasound based concept, so it is 3, and probably cold plasma will be very costly. Okay. Similarly, technology complexity wise, uh, electrotherapy is not very complex, so 5. Ultrasound probably will be again 3, and cold plasma will be very complex. Safety wise, this is moderate safety because you are applying directly voltage or current signal to the human body, so you need to really consider safety concerns. So although it is safe, but we will give 4 rating. Ultrasound is pretty safe, and cold plasma is not, I mean, it is safe, but you need to make sure that your product is safe. As a technology, it is very dangerous because you generate something around 10,000 voltage, and you need to make sure you include proper insulation so that uh, the voltage does not pass to the body via conduction. So basically, because of this insulation, this high voltage and this ground, you only generate electrical potential here, which actually uh, break down water molecules and oxygen to ozone, extra O minus, and H2O to this, then combines with water molecule with in a higher excitation state to create a hydrogen peroxide molecule. Okay, but this is not very safe to manufacture, so we need to take those safety concerns. So I gave a score of 2 here. So ease of use ultrasound is easy. Electrotherapy is a bit difficult. This is I think even more difficult. Portability, all are portable. So I think electrotherapy is 4, ultrasound is 5. This is again 4. Effectiveness wise, cold plasma is most effective. It is has a antimicrobial this thing. This is 4, and ultrasound is 2. So now what happened? Like although some of the criteria got a highest rating, does not mean that this particular concept is the best concept, because here we have weightage across each criteria. So what we need to do, we need to actually multiply these ratings with the weightage, and you need to remember one thing: the sum of all these weightage should be 1, because this is in percentage. So 15%, 5%, 1%, 10%, sorry, 10%, 20%, so 40%. So 40, 60, 70, 80, then 85, 100, 100%. So overall it should be 100% criteria. Okay, so what we need to do next is, like, we need to multiply the ratings with the weightage. So we multiply 15, 5, 0.45, then 5, 5, 0, 0.25, then 0.4, 0.3, 0.8, then this is 1.16, 1.6. Okay, right. 1.6, 8, 3, 4, 2, 5. Oh, sorry, this is 75. Right. Okay. So when we add this, we get some number. Okay. Again, similarly, we need to multiply 15 threes are 45, 0.45, 3, 0. This is 5 threes are 1, 0.15, 5, 0.5, 0.5, then 0.5, oh, this is 1, and this is 0.8. Okay, so 2, 8, 5, 1, uh, 5, 5, 5, 5, 3, 15, 45. Okay, okay, so this is again not 0. This is from previous reference. This is not 0. So now we need to again see for this is rating 1, so means 0 0.15, 1, 0.05, then 2, 0.2. See, getting so low scores. 1, 0.1, 4, 0.8, and see this getting 2.0. So because it has a very high effectiveness, it gets 0. Now when we sum it, probably it's not difficult. Look at, see, 8 plus 1, 9, 11, 11, 11. What is this? 0, 5, 5, 5, 0, 1. Okay, 11, 12, 13, 14, So 2, 3.4. Okay, let's see for this one. 5501, 14, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 30, 31. So 3, 3 plus 1, 4. So 4.1. Definitely now this is highest. Now next, if we sum this 5, 5, 10, right? 10, 0, 1. Then this is 1, right? This is, sorry, this is 1. Okay. So 8, 5, 13, 13, 18, 19, 23, 20, 24, 24, 2, 2 plus 1, 3. So these are ties, okay, but this is definitely winner. So in terms of ranking, we give this is the highest ranking. This is, these two are like second best ranking. So then we can select this particular concept and go for concept testing. And then if we find this is actually working, then probably we'll select this. Otherwise, we'll do go for one of these. So this is how actually we use weightage index method to compare concepts for using scoring method. Okay, so this way actually we can do a comparison between concepts. So here we do not need any standard reference. We can compare concepts based on their individual rating based on the criteria. Okay. So another thing happens is like sometimes the criterias need varying scale or varying rating range or scale. For example, this is again similar example. We have various concepts here. So these are concepts. Okay. So see C1, C2, C4, all these are concepts following this particular technology. C2 to C30 using growth factor. Okay, these are various technology how you can develop wound dressing. Then these are again concepts for electrotherapy, two concepts from vibration, then another cold plasma. There are one, two, three, four, five, six concepts. Okay, so likewise we have based on the various technologies we have a lot of concepts. Okay, now the first level of uh, screening what we do using pug metrics. Next thing what we did was using weighted index method. We compared against concepts and then we selected. But sometimes what happened, like the criterias, these are the criterias basically. The criterias may need varying rating range. They may not use this similar scale. For example, previously we used the same scale, right? So we used 1 to 5 for all the concepts. We just assume something and we just put it. Okay, maybe we consider this as expert opinion. However, for everything we they have a range. Okay, there can be a minimum value, there can be a maximum value, and we consider this range is same and the scale is also same. But when the range and or the kind of the value is not same, for example, when we consider a criteria like FDA 510K, that means is it easy for regulatory clearance. Okay, so FDA 510K is a regulatory rule based on US Food and Drug Administration, and based on that they see this is particular rule. If a particular technology uh, uh, a particular technology have a something predicate device, then actually there are some easy way to go for regulatory approval. Okay. So this is the scale for this particular criteria is 0 or 1. That means do this particular technology have a predicate device? Okay, so yes, no. That means we cannot use a scale like 1 to 5. Okay, either it is 1 or 0. Okay, so this particular for this particular criteria we use the score 1 or 0. Similarly, there's another criteria where we say amount of healing, active healing. So now the scale is different. Now scale is like 1, 2, 3. So 3 means the highest, okay, very good, healing. One is like lowest healing. Second is like medium healing. So here the range is different, right? Sometimes the scale can be also different. So here see negative pressure have a very good, and growth factor have very good healing capability. It is better than electrotherapy and vibration, whole plasma like that. So what we do when we have a different scaling is that we bring everything to the same scale. So if we consider 0 to 1 as a standard scale for our purpose, then what we do, we normalize these values to the scale 0 to 1. So 3 becomes 1. So these are the values after normalization. Okay. So this is how we consider criterias having various rating range, and still we can use the weightage index method to score various concepts. Infection control can be again yes or no. So does it control infection? Yes. Or can it control? Or if it is not, then no. So 0 means no infection control. 1 means yes. So whenever we have something of different rates, we then try to bring this particular criterias and not try to normalize them to something standard which other criteria are also following. So then we can add up the individual concept scores, and then we can place our ranking. Whichever is getting the highest score will rank them highest, like 1. So first ranking is for this 2.5, then second ranking for 2 concepts, 3 concepts. So see, that's why there is a green mark, okay, in this 4. So here we are considering these 4 concepts for further concept testing, for further evaluation. Okay, clear? Any doubt? Okay. Okay, so that's the end of this particular course actually. So this was like a 12 weeks long NPTEL course, and here is a course summary at the end. So this will help you understand an overall objective of this particular course. So let me first give a brief about the overall course summary, and if you have any doubts in between, please feel free to ask. You can use the mic or you can use the message box to ask me any questions whenever you want to clarify some of the doubts. Okay. So in this particular course, we try to define what is product design. So we considered only two aspects of product design. One is form and function. So basically, at a very primitive level, okay, at a beginner level, we can consider a product is basically product have two aspects, a form and a function. And when we say these two entities, we mostly consider tangible products. Tangible products means we are not considering softwares, we are considering physical products. Okay, and it has functions and form. So is more forms is not actually just the outer skeleton or outer structure, it's also the conceptual design, the architecture, okay, the architecture of various functional modules. Okay, and a function is basically the engineering design. Okay, engineering design of the functions, how the product will function. So a product design basically comprise of two design tasks. One is engineering design combined with particular industrial design. So industrial design is basically the conceptual design part, which is designing the architecture, planning for the the human factors, the ergonomics, the aesthetics, everything. And engineering design is taking care the detailed functional decomposition, then engineering of the functionalities, right? Considering various components. So it involves all various engineering activities. So together, this what we call as product design. So this is what we define in our first two lectures. Then we discussed about types of design. So what we discussed was various three types of product design. One was original. Okay, one was then another was adaptive, and then the variant design. So original is basically something which is a basis for all concepts, which like a microchip. Okay, so microchip design enable development of a lot of various products. And before that, we do not have microchips. We used to have transistors, and before transistors, we used to have vacuum tubes. So these are like the major change in technology, which leads to a range of products that come into picture. So those are original designs. Then adaptive design means when you use the original design and try to use it for different purpose. Okay, a microchip can be used for a CD player, can be a TV, can be a refrigerator, can be a washing machine. So these are adaptive design. Variation design is like we have two products, but there's a change in specifications only. For example, two washing machines. However, now we have an incremental design with a better specifications. So in today's world, most of the companies are actually working on variant design. Like they are just increasing or they are enhancing the specification in an incremental way, or they are doing adaptive design. So these are the two things mainly. Most of the design studios or product design companies nowadays are doing. However, original designs are much more respected, and those only involve patent filing. Those are like pure inventions or technology development. Then we discussed about design processes. First, we define like what is a systematic approach. Okay, so why we need a systematic design approach? So systematic design approach is basically when we consider various design tasks in a methodologically way or in a systematic way. So there is no rule that no as a designer you need to follow this particular systematic way of developing a product. However, this makes a process smooth and easy to follow when you actually work on big size projects, and when you need to actually handle large amount of human resources or other R&D activities. And the success or failure rate is very less when we approach things systematically. It is easy to clarify, easy to understand where there happens failure and where things can be improved. So what we learned here, we learned two things. One process we learned was stage gate, which was basically for product design processes, which says that a design process can be break down into stages, and there can be a check gate at every stages. So once you meet that particular checkpoint, that the criteria, then only you are allowed to move to the next. Otherwise, you will not be knowing where actually why your product fails. So it is better always to move forward after you make sure that you actually successfully um, make sure you uh, execute or you compile with that particular checkpoint. So this is what generally we use. Then we discussed about spiral design, which is generally useful for non-tangible like software design. So if we see like uh, if we see like a software like Microsoft Office or any design software like SolidWorks, Pro-E, Photoshop. See, every year you have a version like 2010, 2022, 2023, like that. So from 2000, 20 to 2022 or 2021, when within that there is one particular stage gate process. So this linear stage gate process now actually converted. You can consider it as a spiral design. Again, for again in next year, new goals emerges, and we follow another stage gate process to actually come up with a new version of the same software. So the software basic functions remain same. We just incrementally changes new features. So this is mainly a engineering boost can be thing, and this is more like a customer defined. When we consider a product design, once the product get product launch in the market, there's no way you can actually go and change things at the from the very beginning, and you cannot actually launch a product half done. However, in a software design like which uses spiral design process, actually we can sell something half done if it does not have any bugs. Okay, so that's the difference between a tangible product design process and a software or non-tangible design process. And then we discussed about various product design stages. So basically there are three main product design process. Those can be also break down into several design stages, but basic is three. Like one is understand the opportunity, then develop a concept, then implement a concept. So there are many sub activities for each of these stages. The very first activity for this particular stage, understand the opportunity. After you understand the opportunity, where you do actually customer need analysis, before that actually you need to have a vision. So vision for what actually you want to do, what project or what particular problem area you want to work on. So for that we discussed about S curve to understand how a particular technology moves, and which time where actually you exist. Should you actually use a old technology which actually reach a maturity, or use something new which actually have not matured yet? So those decisions actually to be considered while choosing a particular problem area. So this is what we discussed. Then we discussed how to uh, ask technical questioning. What sort of technical questioning can be asked to come up with a mission statement. So mission statement actually define the boundary of your design. So it defines what all you want to do in this particular design. Then what we do is customer need analysis. So before customer need analysis, we collect customer data. So customer data can be collected by various techniques. So we discuss like Kano diagram. Carnot diagram is one which defines, like, what are different uh, types of products, and what are different relationship with uh, uh, customer satisfaction and need. So how certain needs, fulfillment of certain needs, linearly dependent on the satisfaction, and sometimes, like, even though you provide, meet the needs, you cannot fulfill the customer satisfaction, and sometimes there is no base level satisfaction, but if you actually provide or fulfill that particular need, there is a satisfaction. So different ways, techniques can be used to collect customer information, like interviews. Interviews can be used. Then questionnaire survey can be used. So we discussed something called like dislike method of interview, where you ask a person, like, what you like about a particular product, again what you dislike about a particular product, and then what you want to be improved. So these three questions give rise to the, the aspiration of the customer, and then based on them you actually try to identify the needs. Okay. Then we discussed about how you affinitize the needs. So you try to group a lot of customer, needs into certain buckets or certain categories, so that you can define them in a more higher level order. Okay, something which is more understandable from a functional point of view. Okay, for example, someone can say portable, someone can lightweight. Okay, someone can say plastic body. So all these actually mean the same thing, that you want something too easy to be carried. Okay, so this is like a new name you, the designer, try to give uh, based on various needs that a customer have reported. Again, to understand other sort of customer requirements, you go for activity diagram. So where actually those indirect needs, which are not directly linked to the customer, but they are involuntarily linked to the overall the product life cycle, those can be also extracted using activity design. Okay, activity diagram. So after doing that, what we have is, like, we have a set of needs. Like, we have set of need. Now needs are something very qualitative in nature. Okay, for example, ease of use, lightweight. But based on this, if we try to see one way, several people do. Many industrial designer who are not do not believe, like, going through a engineering design approach is beneficial. They straightly go from needs, which are qualitative needs, to concept generation phase, like that. What happens is, like, when we have needs which are qualitative in nature, and then you try to generate concepts, you end up generating lot of concepts, but those may not be useful in most of the cases. So probably out of 500 you need to reject later, 400 concepts. So it's a waste of time and effort. It is better if we try to go things more systematically, methodologically. So rather than ideating or conceptualizing on qualitative needs, okay, or requirements, it is better we go more methodologically via a product design, systematic approach, where actually first we need to uh, identify, uh, we need to set certain specifications for the need statements. For example, if we say easy to use, Okay, then if you say is portable, okay, and if you say efficient, so these are all qualitative thing. But if you try to ideate on that, no, we'll have very vague ideas, okay, and we'll not it's not, it's again very difficult to convert them into a concrete solution at the end. So easy to use means for a particular product, what may be easy to use. For example, for a bike, easy to use maybe handling. Okay, so if someone is saying like, okay, bike handling has to be easy, that means you need to consider the weight distribution, right? Weight distribution across the bike. Okay, so now you need to think like, okay, the CZ needs to be low, okay, so that it is easy to be handled in a high traffic scenario. So specification wise, you need to see, okay, the CZ, center of gravity, needs to be low. So now this is not a solution, but one of the specification. There can be many different specifications which actually can say this particular thing easy to use. Okay, for example, easy to use maybe again for a bike became a very complex thing. But for example, if it is a handheld, for example, electric saver, easy to use maybe, very minimum buttons. So you can say number of buttons only 5. Okay, similarly, easy to use maybe like, okay, easy to, like easy to grip, like for example comfortable grip. So maybe the softness or the rubber softness maybe some unit. So a specification basically means coming out with a value and a matrix. A matrix is something like a unit of measure, like kg, meter, mass, like that, and value is something like a numerical value. Similarly, portable can be like weight of particular product. So 50 kg. So if it's a less than 50 kg is good, okay, good. Efficiency may mean lot of things, but for particular product, for example, if we say medical device and efficiency of the medical device is high, has to be high. That means healing time needs to be short probably if it is a wound healing device. So that means you can say like, okay, specification wise, the outcome should have a healing time which is less than 12 hours. Okay, without setting this, if we try to conceptualize ideas from the need statement, actually we may not realize based on what we are actually generating concepts. We will generate concepts which actually a lot of them will get rejected when actually we try to make some sort of concrete solution. Okay, so what we do next is product identifying constraints and functions. Okay, so we have a list of specifications. Okay, now some of the specifications can be considered as constraints, and some of them are actually functions. Okay. For example, if I say the weight of the bike should not go more than 180 kg, so that is a constraint. That is not, that is not something a designer has to plan to compromise on various functionalities. Okay, so that is something like a constraint. A functionality is more something like, okay, engine power should be at least 350 horsepower or bhp. So 350 is too much. Okay, 35 bhp. So 35 bhp achieving is a functionality that he needs to meet with the design of a cylinders or engine piston. Okay, but weight of the bike, which at the end needs to be less than 130, it's a constraint. Okay. Similarly, there can be other constraint like it it should not get off balance. Okay, if you load 200 kg, so that's a constraint. when I say functionality, it should be able to load 200 kg is a functionality. That means here we need to make provisions how 200 kg can be loaded in a bike. It's a functionalities we need to add. However, it should not fall is a constraint. Okay, so do not, we need to just consider that it should not fall, but design accordingly to carry that particular 200 kg. So that's how we need to distinguish between constraint and function. So what we do after that, we come up with various functional models. So for functional models, we discuss, like for simple products we use method like SOP, then fast method, okay, and then complex products we use flow model for so all of these are functional decomposition done for products. So these are various functional modeling techniques. For simple products, we can represent a product functionality as a tree structure, whereas for the complex products it cannot be represented as a tree structure. It has to be more like a structure, okay? More like a network of interrelationships between, it's more like a graph, not like a tree structure, okay? So after we have a structure or a tree for a particular product, next is like deciding upon product architecture, and this is basically what influences the product form. So when we consider product form, it's basically the enclosure, which also involve the aesthetic part, the ergonomics part. It also involve how the architecture is designed, how the functional modules have been planned. So in product architecture planning, what we considered is like two type of architecture. One is product family architecture. Product family architecture means when we have a range of products for from the same company, then we need to make sure some products is for some particular customers, probably some particular product is for some other groups. Okay, so we discuss like how to select. Okay, we discuss like there's a particular flow chart, like how, and based on statistical data, how we can decide on what sort of architecture will be requiring. Okay, so that is what selecting a particular architecture. Then we discussed about product architecture. So in product architecture, we talked about how for a particular product, how various functionalities of a products has been grouped together. So basically, product architecture can be like a modular, okay, and another one is something which is uh, integrated, integral. Okay, so integral is something where the functionalities cannot be separated. So there is only one particular functionalities, and you cannot break down the products parts in terms of different functionalities. And the modular design is something which have different functionalities. So here we discuss about how to, next is what we discussed was how to create functional modules. So we discussed two methods. One is a basic clustering method, which is basically after a flow model you try to group various functionalities based on how they are associated with the input flows. Okay, if there is a flow of energy commonality, if there is a common use of material, then in terms of that you can actually group them together. Again, at the end you need to also consider how to actually insulate each module in case there are some exchange of material or heat which can actually affect the other module. Okay. The other method is the hierarchy method. Hierarchy method have some sort of rules. For example, uh, longest path. Okay, okay, and then you can have energy change. Okay, so whenever there is a transformation of energy or transformation of material, so then you can consider a break, okay, in break point, where you can actually group functionalities into separate modules. So one is a hierarchical approach, another is a basic clustering approach. And then we discussed about concept generation phase. After we have the product modules, now we need to think about the form. So in terms of form, now we have what we have so far actually are more like the very generic ideas. Okay. However, in terms of detailed visualization, we need to have some sort of sketches or representation of these modules or the functionalities. So for that, what we do, we use some sort of again systematic approach. So we use concept generation methods, the intuitive methods we discussed, like brainstorming, then 65. So we consider references, informations from various sources uh, to ideate concepts. Then we have a logical method, which I already discussed at the beginning of this particular class, like trees or tips, and finally the concept selection. So concept selection again can be break down into concept screening and concept scoring and testing. Okay. So concept scoring, what we discussed is previously when we have large chunks of uh, concepts, and then based on certain reference we try to select some of the concepts. So certain metrics that we can use is Pugh's matrix or Pugh's matrix. And in terms of concept scoring, when we try to compare the in between various concepts, then we use something like a weightage index method, concept scoring, where actually we set some sort of criterias, and then accordingly we set the required weightage for those criterias, and then actually we give rating and then multiply the ratings with the weightage to get the actual score. Okay, so with concept scoring, actually we can compare concepts among themselves, and then finally select or rate particular concepts, which further can be, which further we can use for concept testing phase. Okay, so that's the end of today's class. If you have any doubts, okay, and that's the end of this particular course also. So these are all the various topic areas. I just tried to brief them in a short amount of time. So if you have any doubts, please feel free to ask. Okay, then. Okay, thank you and all the best for future courses. And please finish the assignment on time. And if you have any doubt, you can contact me. Thank you. Thank you. Thank you very much.